Hi guys, welcome to your Unit 7 Lesson 1 notes on prime factorization. By the end of the day, you will be able to write the prime factorization of a number. Prime factorization is just listing factors that are prime. Now, a prime number only has two factors. The first factor is going to be 1, and the other number is going to be itself. They're called prime because they're the best. Mathematicians love prime numbers because they're like the building blocks of all numbers. So examples of prime numbers, we say that 1 is not prime because it only has one factor, 1. Okay, so prime factors include 2, because 2 times 1 is 2, 3, but not 4, because 4 is divisible by 2. 5, but not 6, because 6 is divisible by 3 and 2. 7, but not 8, because 8 is divisible by 2 or 4. But not 9. 9 is divisible by 3. 10 is divisible by 2. 11 is prime. So prime numbers are not divisible by anything except for themselves. So this is the start of literally an infinitely long list of prime numbers. Other prime numbers include 13, 17, 19, not 21, 23, 20, not 27, 29, 31. You'll notice that these are all odd because if they're even, they're divisible by 2, and that's not 1 in itself. The only exception is, of course, 2 itself. 2 is the only even prime number. So that's exciting. If you want to learn more, we can talk more about prime numbers in class. Prime numbers, we call them the building blocks of all other numbers. They're the building blocks of mathematics exactly because you can't break them up into anything else. They're as basic as you get without being literally one. Now, our key idea of the day is prime factorization. Remember that a factor means to multiply. You multiply two factors together to get another number. Okay? So prime factorization is a way to write that number as a product. Product also means multiply. A product of prime numbers. Basically, we're just going to do a bunch of examples. Now our key idea, one of my favorite things in all of math, you know what, I think it is literally my favorite concept in all of mathematics, is called the fundamental theorem of arithmetic. It's fundamental, it is key, it's the key idea of all key ideas. It's so basic. We're going to put the fun and mental and fundamental, and here's what the fundamental theorem of arithmetic says. It says that each integer has a unique prime factorization. This means that when you write the prime factorization of a number, that's like that number's DNA. It's like a recipe for building that number. And how you find the prime factorization of a number is you make factor trees. So when I look at a factor tree, I want to figure out what can I divide out of this number. For example, I look at 99, and I know 99 is divisible by 9, so that's cool. We've got 9. In fact, I'm just gonna write these in black. 99 divided by 9 is 11. And then 9, we're going to do some more dividing here. 9 can be divided by 3. 9 is 3 times 3. Now, in these factor trees, specifically on this example, or rather, on factor trees, this one uses factor trees. This example does not use factor trees. But when you're using factor trees, you always want to circle a prime number. So 11 is circled. Oh, wait, hold on. We made prime numbers blue. Okay. You always want to circle a prime number. So prime numbers are 11, 3, and 3. And then you always want to put in a box not prime numbers. We call those composite numbers. Just think not prime. So if that number can be broken up into smaller numbers, put it in a box. So you'll notice that like 9 can be broken up into 3 and 3, so that goes in a box. 99 can be broken up into 9 and 11, so that goes in a box. If it cannot be broken up, we put it in a circle and call it prime. Let's make these green, why not? So since 99 and 9 can both be broken up, we put them in a box, otherwise they go in a circle, and then each line represents a division happening. Ooh, cool. So then we can write, in order to write the prime factorization, we take all of our circles and we multiply them together to get our main guy. So we say 11 times 3 times 3 equals 99. Now that's the order that we found them in this tree. That just happens to be the number that we picked. When you actually write the prime factorization, you need to write them from smallest to biggest. So you get 3 times 3 times 11 equals 99. And then if you have any repeats, see we have 2 3s here. Remember 3 times 3, that's the same thing as 3 squared. So we can also use exponents as well. So this is going to be our final answer right here. If ever we have repeats, write it as a power with exponents. And then, so yeah, 3 squared times 11 is 99, which is true because 3 squared is 9, 9 times 11 is 99. So what we did in this prime factorization is we took our top number, 99, and we kept breaking it up into tinier bits. That's what we'll do here on number 2 as well. Look at 76. Now we need to come up with a prime number times a composite number. My favorite go-to is I just look at the list and I just kind of start from the bottom and then go up. Always start with 2. If it's even, always start with 2. Get rid of that 2. So we're going to say that 76 is 2 times, well, 76 divided by 2 is 38. Oh, hey, look, we have another even number. 38 is still even, so I'm going to go with 2. It's very exciting. Okay, and we circle that because you can't break up 2 anymore. 38 divided by 2 is 19. We can't break up 19 anymore either. It's not divisible by 3 or 5 or anything. So we're done. So that tells us that 2 times 2 times 2 equals, nope, that's not true. 2 times 2 times 19 equals 76. That's an equals 76. And again, we only include our prime numbers, 2 times 2 times 19. And since we have 2 2's, not like the ballerina kind, but the multiple of 2 kind, that's the same thing as 2 squared. So 2 squared times 19 equals 76. Let's do one more example. I'm going to do this example twice because there are several ways to do this. When we look at number 24, again, I like to start with an even number. 24 is divisible by 2. 24 is 2 times 12. 12 we can break up. Look, 12 is even. So let's break that up into 2. 12 divided by 2 is 6. We can break up 6 even more. We can break that up, so we'll put it in a box. 6 is still even. It's 2 times 3. So check this out. According to my circles, 24 is, shoot, I'm running out of room. Okay, 24 is 2 times 2 times 3 times 2. I started here and I went around this way. 2 times 2 times 3 times 2. Again, we're only including our prime numbers here. Now I have a 2, but I have 3 2's in here. 1, 2, 3. So we have 2 cubed times 3. And that's what 24 is. 24 is 2 cubed times 3. But check it out. This is not the only way to fill it. What if instead of breaking out a 2 first, the first prime we pulled out were a 3? That would give us 3 times 8. 8 we can break up into 4 times 2. Again, keeping our prime number in our circle, our composite that can be broken up in a box. And then 4 is 2 times 2. 2 we cannot break, so it's done. 2 we cannot break, so it's done. But check it out. We still get that 24 equals, look at all those circles. 24 equals 3 times 2 times 2 times 2, which is, oh hey look, 3 2's there. So it gives us 24 is equal to 3 times 2 cubed, which is the same thing as 2 cubed times 3. So it doesn't matter where you start, you'll still go the same way. Okay, so here we go. Take your factor tree idea, and you'll want to draw factor trees in order to find a prime factorization. So we start out with 63. And we think, can 63 be broken up into anything? Well, yeah, I immediately see that 63 is 7 times 9. It's not the only way to break it up, but that's the way I went. 7 we can't break up, but 9 we can. 9 can be broken up into 3 times 3. 3 cannot be broken up. 3 cannot be broken up. So we only write our prime factors here in the prime factorization. We say that 63 is equal to, and always start with the smallest ones, 3 times 3 times 7. Now we do want to write those with exponents. So that's the same thing as 3 squared times 7. And now we are done. Let's do it again. Let's look at 39. When I look at 39, I see a lot of 3's in there. This one, you guys, I'm going to do without color coding. We're going to just do shape coding. Okay, so in 39, I see a lot of 3's. 39 divided by 3 is 13. Okay, 3, I know I cannot break up anymore, so I'm going to circle it. 13, I also can't break up anymore, so I'm going to circle it as well. Cool. So it tells us that 39 is 3 times 13, and that's it. That's the prime factorization. We're done. Okay, I've got one more. Let's look at 7. Okay, we're starting out with 7. 7 can not be broken. That's it. It's done. The prime factorization of 7 is just 7. Ta-da! Alternatively, if you just want to say like 7 is prime, that's also completely valid. That's a valid answer. You can leave it like that. Okay. Now notice whenever we write the prime factorization, we always put them from smallest to biggest, smallest to biggest, smallest, sorry, this is the key answer right here. Smallest to biggest. Okay. So there are 2 important takeaways. The first one is to use factor trees. Remembering to circle prime numbers and to square composite numbers. And your second key idea is to write the prime factorization. So we'll say list your prime factors from smallest. Actually, let's do least. That's fewer letters. From least to greatest. And use exponents. So those are your 2 key ideas. The third key idea is to have fun. Enjoy it. Have a great time on your homework.